In the midst of the excitement that was last weekend where everybody was seeing the Northern Lights, I wanted to make a video explaining what exactly are the Northern Lights anyway? We're getting all hyped up about it and saying, oh my gosh, they're so beautiful, but this begs the question of, scientifically speaking, what is going on here? Spoiler, it was pretty cool, so let's talk about it. Alabama isn't somewhere that you'd think to see the Northern Lights, but last weekend, a strong solar storm made this possible. Last weekend was unique, and in fact, something like this hasn't happened since October of 2003, which was quite a long time ago. This is the first video in a mini-series that I'm doing featuring the Northern Lights, but in order to get into talking about why last weekend was so special and cool, we first have to understand what are the Northern Lights anyway. The Northern Lights make up 1/2 of the phenomena that we know as the polar lights. The Northern Lights, aka the aurora borealis, is most well known, but it's important to note that we actually have southern lights as well, called the aurora australis. Australis? Something like that. We see polar lights at both ends of the Earth, and this fact that we see them at both ends of the Earth actually is very telling about the properties of the Northern Lights, but we'll get to that. So now, to begin answering our question, we have to take a trip all the way over to the sun. I don't know why I'm pointing this way. The sun is definitely up that way. I don't know what's over there. I think there's a Chick-fil-A over there. We are heading over to the sun because the polar lights originate not on Earth, but at the sun. Basically, the Northern Lights start out with the sun shooting a massive expulsion at us, which sounds rather violent, and that's because it is, but it's a beautiful kind of violent, so I guess that's cool. As you know, the sun is a fiery ball of energy, and it is constantly releasing this energy into our universe. It releases this energy in the form of heat, in the form of light, and also in the form of positively and negatively charged particles that we call plasma. Plasma is sort of like electrified gas, which I thought was kind of ridiculously cool. People call plasma the fourth state of matter, and it occurs when atoms are superheated enough to separate their protons and their electrons, thus creating an electrical charge. Electrons are negatively charged and protons are positively charged, so when you separate them out, you have something that has a negative charge and something that has a positive charge. We know that when we heat up a liquid, it boils and turns to steam. Well, if we take this steam and heat it even more, and I'm talking like superheat that, then we eventually will get plasma. Now, plasma may sound super cool and unique, and while in my opinion it is super cool, it is actually not that unique. In fact, plasma makes up about 99% of our visible universe. All of the stars that we see in the sky, including our very own sun, are made up of plasma. So as I said, the sun is releasing energy in the form of plasma, and this is pretty much constant. And in fact, this constant release of energy in the form of plasma is something that we call solar wind. Solar wind is a continuous stream of plasma, aka electrified protons and electrons, flying off of the sun towards us. And when I say flying, I do mean flying, because these particles are coming in hot. Solar wind moves at a speed of between 190 miles and 500 miles per second. And let that sink in for a second, because that is lightning fast. Good job! But wait, didn't I say that the Northern Lights are caused by a massive expulsion? I sure did say that. And here is where things get really interesting. I am spinning this way, and I don't want to be spinning this way. Periodically, the sun absolutely launches massive amounts of these charged particles into space. So it's basically like if solar wind was a gentle breeze, this massive explosion is like hurricane force winds. These explosions travel much faster than everyday solar wind and can be as fast as 1,860 miles per second. These are known as coronal mass ejections. The word coronal is used here because coronal mass ejections, in addition to solar wind, all come from the outermost layer of the sun, its corona. Fun fact, this is the part of the sun that you can look at during a total solar eclipse, which, if you're interested about total solar eclipses, because one just happened and it was pretty darn cool if I do say so myself, I happen to have a bunch of videos on that, so definitely be sure to check those out. It is now time to leave the sun, which is up there, not over there, and accompany our plasma all the way to Earth. The length of a journey of a coronal mass ejection from the sun to the Earth varies. Even at its lightning-quick speeds, it can take several days for the plasma to reach Earth. But finally, the plasma does reach Earth, and things get even more fascinating. Our Earth is protected by a magnetic field, which is essentially a giant shield that is generated by the molten iron in its core. The magnetic field protects us from solar radiation and also provides the basis for us to navigate with a compass. Our magnetic field actually deflects most of the plasma coming in from the sun, but it doesn't deflect all of it. Some of the plasma gets captured in the magnetic field and is quickly funneled towards the areas of greatest magnetic pull on the planet, the North and South poles. And this makes sense. The plasma has a positive and negative charge, and the poles of our Earth have positive and negative charges. So they're going to be attracted to each other. And this is exactly why we see the northern lights mostly at the poles and not all around Earth. So now it's time to go to the poles, and this is where things get super exciting. It is here that the particles from the sun collide with atoms in our atmosphere. And remember, I said that these particles are coming in hot, so they are colliding with oxygen, nitrogen, and other elements in our atmosphere and transferring all of their energy over to them. When I say transfer all their energy, I mean they're transferring their electrical charge, their heat, to these atmospheric evidence. And when this happens, these elements become excited, a term in chemistry that refers to them ascending to a higher energy state. And a fascinating and beautiful property of excited atoms is that here they begin to light up and glow. And right here is where we see the beautiful lights and colors of the northern and southern lights. So, in short, the northern lights appear because high energy particles from the sun are slamming into Earth, transferring their energy to its atmosphere and making it glow. Light is a form of energy, and the lights of the auroras are showcasing the energy from the sun that made its journey all the way over to our planet. And there you have it. That is our answer to the question of what exactly are the northern lights anyway? This is the first video in a mini-series that I'm doing on the northern lights, so if you'd like to learn more about them, as well as why last weekend was so special, or even just learn more about nature and science, because that's what my channel is all about, definitely stick around so that I can see you in the next video.